So this is Python Tute04A, and this is looking at while loops. And while loops enable us to repeat through a block of code until a specified exit condition is met. So let's just set one up now. So before I start a while loop, I often have to create a variable or a placeholder in which to be able to test my exit condition. So my exit condition needs to be either true or false. And the while loop for this one is going to be a command. So we're going to use command is equal to a string like so. And then we're going to ask that while the command is not equal to, so exclamation mark equal to is not equal to, exit in capital letters, then we're going to do what is in the list. So we're going to say command is equal to input, and in here I will put what do you want, question mark, space, 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 and then we've got that happening there, and that's going to actually wait or go through that loop as many times as it needs to do until you get the right command, which is exit, in which case it'll finish the loop and unceremoniously dump us back out into the main line. So using indentation to maintain access to the loop, so everything that's indented below here will be in the loop. So let's run this. So I'm going to go run. Let's run it without debugging. So you can see down here it says, what do you want? Nothing. And it'll ask me what do I want until I type in exit, and then it will go out. And it's going to go through all these other print statements here, but that's the first loop that is done. A neat way of controlling the exit condition is by setting a variable and using a loop counter. This way you can actually set the loop to run through as many times as you want. So I like to use, for example, a letter. A is a good one, but I'm going to use the variable called counter. And the variable called counter is going to be equal to 0. And I'm going to set the condition up while the counter is less than 20. I'm going to do the loop. Now here's the thing, is I want the loop to actually just print out the value of the counter. And each time though, for this loop to actually finish, I need the counter to increase by 1. So I can say counter plus plus, and that should increase by 1. I prefer to do it in Python by saying plus equals 1. That actually works more nicely in Python. Plus plus is not actually a command that I can use. So that's going to go while counter is greater than, less than 20. It's going to print out the value of the counter, and then when it gets to 20, it's going to then finish off. So let's run this through. Run without debugging. So I need to type in here exit. It gets a bit annoying, but that's how it is. And now it goes through and it counts to 20. Now if you want to do it so that it actually gets to 20, if you put the counter in front, so command control X to cut that, and we put that there. So where you do the counting up is important. So run without debugging, exit, and now it actually gets to 20, starts at 1 and gets to 20. So you can see there that even though it goes to 20 here, the loop will still continue through and then go back to the test before it counters. It doesn't break out early of the loop. So we can actually set a break up early. So I'm going to use the same loop. I'm going to press Control C. And we can set up an early breakout by doing this. Control V. And I can say if counter equals 0, I'll go 10, so halfway through the loop, then we can just break it. I'll put a thing in here. We're going to set an early condition, and we can just break the loop by typing in the word break. So that's going to break out of this loop altogether and bring us back to the end here. So let's just run that through. Down here, I'm going to type in exit once again in capital letters, and it says, yep. Oh, I didn't set counter back to 0. Counter is equal to 0. Silly me. So the condition of the loop was already met before it actually even started, so it didn't even go through that loop. So I'm going to go run, start debugging, and then exit, press enter, and early condition. It says that there, broken loop done. So the final thing to do now is to look at the idea of a list loop. So you can step through a loop with a list. And there are better ways of doing this, but this is one way you can actually step through a list. So I'm going to create a list, and my list is just going to be equal to a bunch of numbers. So just randomly type them in. Okay, so we've got all those numbers sitting there, and I'm going to then set my counter. This time I'll set it to be my index, my I for index. I actually shouldn't use the word index. And for first index is going to be equal to 0. And then we're going to use the while loop. While, and we're going to say I is less than len of a list. That's the length of the a list. We're going to step through and print out each value. Print a list I. And then we're going to I plus equals 1. And then we're going to exit that list, and let's see how that goes. So let's just should, in theory, just print out those numbers in order. So let's just run without debugging. I'm going to exit, and I've got a little a list versus a list. There we go. Should notice that they didn't turn blue. Run that again, exit. And there you go, it put out those in order of being done, and then finish it off. One final use of loop, of the while loop, which is a little bit annoying possibly, is this one here, the while true loop. This is not really good programming to do this, although it sometimes is useful, particularly when you're programming a hardware system in a Raspberry Pi. You just want it to go forever. In theory. So while true, and we can let's just print out hello. Okay, and if we run this now, run without debugging, if I type in exit, it's just going to say hello forever continuously until I press Control C to end that thing. So that will actually break out of that. So not recommended that you do this, but you can do this for testing purposes. Can be useful in certain situations like games, that sort of stuff, but it's always better to have an exit condition that you're expecting to be able to get out of.